Hi, this is Tutor Malvis, and in this video we are going to be talking about matrices and determinant. So what is a matrix? A matrix is a rectangular array of numbers in rows and columns enclosed within brackets. So the way we recognize a matrix is the way it is arranged. Anytime you see this array, it means arrangement. So a matrix is usually arranged in rows and columns. So when you have something like this, 2, 3, -5, 1, or you have 1, 3, 5, or you have 7, 0, 4 enclosed in brackets, these are all examples of matrices. Alright, so matrix is singular, matrices is plural. And the numbers in the brackets are known as the elements of the matrix. These numbers here, they are called the elements of the matrix. For instance, if you have a matrix A, let's say A is A11, A12, A21, and A22. Okay, these members A11, A12, A21, A22 are known as elements of matrix A. Now, what does A11 means? It means the position of this particular element is first row, first column. First row, first column. All right. Then A12 simply means first row, second column. A21 means second row, first column. While A22 means second row, second column. So anytime we talk about element of a matrix, is very important that we also talk about the positions of the elements of the matrix. All right. For instance, look at this example. If we have matrix P to be -2, 3, 0, matrix 5, 6, 4, 1, 7, 2. All right, this is a matrix. Now, if you are told to find out A21, A32, A23, A33, all right. So since this is A21, it simply means second row, first column. How do you recognize the rows? This is row 1, this is row 2, this is row 3. This is column 1, column 2, column 3. So second row and first column. So this is the second row and this is the first column. So the one at the middle is 5. So the A21 is 5. All right. Then for A32, we are going to locate A32. A32 is third row, second column. So third row, second column. So that is 7. Then we have A23. A23 simply means second row, third column. So second row and third column. So that is 4. A23 is 4. Then we have A33. A33 simply means third row and third column. So that is 2. So this is how to identify elements of matrices. So let's talk about the order of a matrix. Now, when we talk about the order or dimension of a matrix, it is the ordered pair having as first component the number of rows and as second component the number of columns. So, how do we represent the order of a matrix? For instance, if I write 2, 3 or 2 by 3 or 2 times 3. These are the different ways by which the order or the dimension of a matrix can be represented. So the first component of this order is the number of rows of that matrix, and the second component is the number of columns of the matrix. So let's say we have matrix 2, 3, 4, 1, 5, 6. How many rows does this matrix have? We have row 1, we have row 2. How many columns? We have column 1, column 2, column 3. So we call this 2 by 3 matrix. It is 2 by 3 because it has 2 rows and 3 columns. Don't forget, you always mention the row first. So it's either you write it 2 by 3 like this, or you write 2, 3 or 2 times 3. But it is read as 2 by 3 matrix. If you have 1, 4, 0, 7, here we have 2 by 2 matrix, that is 2 rows, 2 columns. If you have 1, 6, minus 2, here we have 3 by 1 matrix because we have row 1, row 2, row 3, and we have only 1 column. So this is 3 by 1 matrix. So this is how to identify the order of a particular matrix. So let's talk about the types of matrices. Types of matrices. Alright, the first one that we want to talk about, we have the row matrix. Now, what is a row matrix? A row matrix simply is the matrix that has only one row, that is a single row, and any number of columns. Example is 2, 3, 1. So here we have just one row and we have 3 columns. So this is 1 by 3 matrix. So any matrix that has just one row is known as a row matrix. Similarly, any matrix that has just one column is known as column matrix. Let's say we have 2, 3, 1. So here we have 3 rows and 1 column. So this is an example of column matrix. Then we have null or zero matrix. Now, if all the members or all the elements of a particular matrix are 0, like 0, 0, 0, 0, this is called a null matrix. Then number 4, we have a square matrix. We have a square matrix. Square matrix simply means a matrix containing the same number of rows and column. Example, you have 2, 5, 1, 3. This is a 2 by 2 matrix. You have minus 1, 0, 5, 7, 2, 11, 6, 1, 3. This is a 3 by 3 matrix. Whether it is 2 by 2, 3 by 3, 4 by 4, 5 by 5 matrix, so long we have equal number of rows and columns, it is known as a square matrix. Then number 5, we have what we call scalar matrix. Now, what is a scalar matrix? A scalar matrix is a diagonal matrix in which all the diagonal elements are the same. For instance, if you have k, 0, 0, k, you notice that all the elements here, this is what we call the leading diagonal. All the elements here are the same. You call it the main. So looking at this, we have K0, 0K. You'll notice that we have K on the main diagonal or the leading diagonal or the principal diagonal. So when you have a matrix and all the elements on the leading diagonal are the same, for instance, you can have 2, 0, 0, 2. This is an example of a scalar matrix. I can have 5, 0, 0, 0, 5, 0, 0, 0, 5. This is also an example of scalar matrix because all the elements on the leading diagonal are the same. So a similar one to scalar matrix is the sixth one, what I call identity matrix. An identity matrix is a scalar matrix in which the diagonal elements are all 1, like 1, 0, 0, 1, or 1, 0, 0, 0, 1, 0, 0, 0, 1. When all the diagonal elements are 1, then you have identity matrix. So let's talk about equality of matrix. Equality of matrix. Now, when do we say two matrices are equal? Two matrices must have the same order for them to be equal, and their corresponding elements must be equal. So let's say we have matrix A to be A11, B1, A11, A12, A21, and A22. Then we have another matrix B, B11, B12, B21, and B22. So the first thing you are going to notice is that they have the same order. Matrix A is a 2 by 2, matrix B is a 2 by 2. So the first condition has been satisfied. So for them to be equal, for A to be equal to B, their corresponding element must also be equal. So A11 must be equal to B11, A12 must be equal to B12, A21 must be equal to B21, and A22 must be equal to B22. So we are going to be applying this concept in solving problems. So look at this question, for instance. Given that x2 minus 4y is equal to 3, 2 minus 4, 1, and we are told to find x and y. So going by the principle of equality of matrices, we can say x is equal to 3 and y is equals to minus 4. So x equals to 3, y equals to, y equals to 1. X equals to 3 and y equals to 1. So this is how to apply the knowledge of equality. So even if what we have is x, y, w, z, all right, and you have 3, 2, minus 4, 1, the implication is that x is equals to 3, y is equals to 2, w equals to negative 4, and z equals to 1. So let's talk about addition and subtraction of matrices. When two matrices are of the same order, their corresponding elements can be added or subtracted from each other. So it means that you cannot add or subtract. You cannot add or subtract matrices of different orders. So for you to be able to perform addition or subtraction, the matrices must be the same. For instance, if you have 3, 1, and you want to add it to -1, 3, 2, the first matrix here is 2 by 1, and this one is 3 by 1. So this operation is impossible. You cannot add them. So for you to be able to add them, they must be of the same order. So let's look at an example. We have matrix A to be 2, -4, 3, 1. Then we have matrix B to be 1, 4, -2, 3. Then we want to find A plus B and want to find A minus B. So let's check out how to add and subtract two matrices. So here we have it. If we are adding these two, what we'll simply do is you take these two, you add it to this one, take this -4, you add it to this 4, take this 3, add it to this -2, and take this 1, add it to this 3. So that will be 2 plus 1, that is 3. -4 plus 4, that is 0. 3 plus -2, that is 3 minus 2, that is 1. Then 1 plus 3, that is 4. So the addition of the two matrices give us 3, 0, 1, 4. What if we decide to subtract them from each other? We have 2 minus 4, 3, 1, minus 1, 4, minus 2, 3. Okay, so that will be 2 minus 1, that is 1. Minus 4 minus 4, that is minus 8. 3 minus minus 2, that's 3 plus 2, that is 5. Then 1 minus 3, that is minus 2. So this is how to go about the addition and the subtraction. And this is also true for 3 by 3 matrix, because this is an example of a 2 by 2 matrix. It is also true for a 3 by 3 matrix. For instance, if you have 3, -1, -2, 2, 3, 1, and you are told to add to 2, -2, 3, 1, 3, 0. So just take the first element here, plus you add it to this one, you have 5. That is 3 plus 2. Then -1 plus -2, that is -3. Then -2 plus 3, that is 1. That's like saying 3 minus 2. Then 2 plus 1, that is 3. 3 plus 3, that is 6. 1 plus 0, that is 1. What is the order of this matrix? This is a 2 by 3 matrix. 2 rows, 3 columns. Next, let's talk about scalar multiplication. So let's start by dealing with multiplication of matrices. And the first aspect of it is the scalar multiplication, where if you are given, let's say matrix A, you are given matrix A to be 2x, y, 0, and you are told to find 3a. Alright, so this is what we call the scalar multiplication, where you have to multiply the whole matrix by just one constant term. So to evaluate this, 3a is going to be 3 into matrix A, and you will simply use 3 to multiply all the elements in that matrix. So 3 multiplied by 2 is 6, 3 multiplied by x is 3x, 3 multiplied by y is 3y, and 3 multiplied by 0 is 0. So this is how to find the scalar multiplication of matrix A. Then we have, if we have x, matrix x equals 4, negative 11, negative 8, 3, and matrix y as negative 5, 1, 0, 6. And we are told to find A, 2x, B, negative 3y, C, 4x minus 2y. So how do we tackle this problem? So the first thing is to find 2x. So 2x will be 2 into 4, negative 11, negative 8, and 3. So you multiply all of these elements by 2. 2 times 4, you have 8. 2 times negative 11, that's negative 22. 2 times negative 8, that is negative 16. 2 times 3, that is 6. So we are through with A. Then we have B, negative 3y. Alright, that will be negative 3 into matrix y, 0, 6. So you multiply the whole element by negative 3. So we have negative 3 times negative 5, that is 15. Negative 3 times 1, that is negative 3. Negative 3 times 0, that is 0. Negative 3 times 6, that is negative 18. And this is the answer to option B. Then for the last one, we have 4x minus 2y. 4x minus 2y will look like this. 4x, this is x, minus 2y, this is y. Alright, so this is going to be 4 times 4, 16, minus 44, minus 32, 12, minus, use 2 to open this bracket, we have minus 10, we have 2, we have 0, we have 12. So simply perform the arithmetic. 16 minus minus 10, that is 16 plus 10, that's 26. This 16 minus minus 10. Then minus 44 minus 2, that is minus 46. Then minus 32 minus 0, that is minus 32. Then 12 minus 12, that is 0. So the answer to option C is 26 minus 46 minus 32 and 0. So here is a question that we need to tackle together. 5 into 4, 3, 7, 3 minus 2 into 1, 4, 3, 2 equals W, X, Y, Z. And we are told to find X, Y, W, Z. So the first thing you will do, looking at this, is you find the scalar multiplication or the scalar product of this, and also find the scalar product of this, and whatever you get, you subtract from each other and equate to this. So let's start with this one. 5 times 4, we have 20. 5 times 3, we have 15. 5 times 7, we have 35. 5 times 3, we have 15. Minus 2 times 1, we have 2. 2 times 4, we have 8. 2 times 3, 6. And 2 times 2, 4. Equals the unknowns given to us. Alright, so let's subtract them. 20 minus 2, 18. 15 minus 8, 7. 35 minus 6, 29. 15 minus 4, 11, equals to W, X, Y, Z. Alright, so going by the equality of matrices, 18 is equals to this, 7 is equals to this, 29 is equals to this, 11 is equals to this. So we can conclude by saying X equals to 7, W equals 18, Y equals 29, and Z equals 11. So this is the solution to that problem. So let's see how to multiply two matrices together. How do we multiply two matrices together? Let's say we have matrix A to be 3, 2, 1, 4, and matrix B to be 2, negative 1, 0, 3. Okay, if you are multiplying A and B, it can be written as A times B, or A dot B, or AB. Alright, so the product of these two matrices will be a matrix C, where the elements of C are C11, C12, C21, C22. Now, what does this connote? AB will be equals to C11 means first row, first column. So we are going to pick first row here, and first column here. That's the first thing we are going to pick. Alright, so that will be 3 times 2. What do we have? We have 6, plus 2 times 0. We have 0. So we are done with C11. So let's go to C12. C12 simply means first row, second column. So 3 times negative 1, that is negative 3, plus 2 times 3, that is 6. So we are done with C11 and C12. So remaining C21. What is C21? It means second row here, first column here. So that will be 1 times 2, that is 2, plus 4 times 0, that is 0. So we are done with C21. Let's go to C22. C22 means second row here and second column here. So that will be 1 times negative 1, that is negative 1, plus 4 times 3, that is 12. So if we perform this arithmetic, we are going to have 6 plus 0, that is 6, minus 3 plus 6, that is 3, 2 plus 0, that is 2, and minus 1 plus 12, that is 11. So the product of these two matrices, we have 6, 3, 2, 11. Here is another example. Given matrix M equals 3, 2, 1, 4, find M square. So M square simply means M multiplied by M. So it means we are going to multiply this matrix by itself. So that will be first row, first column. 3 times 3, 9. Plus 2 times 1, 2. First row, second column. 3 times 2, 6. Plus 2 times 4, 8. Second row, first column. 1 times 3, 3. Plus 4 times 1, 4. Then second row, second column. 1 times 2, 2. Plus 4 times 4, 16. 9 plus 2, we have 11. 6 plus 8, we have 14. 3 plus 4, we have 7. And 2 plus 16, we have 18. So this is the answer to this problem. Now let's consider multiplying matrices of different order. Now, unlike addition and subtraction, where the order must be the same before you can find the matrix, It is not so in multiplication. The order may not be the same, but what must be the same is the column of one must be equal to the row of another. Like this one now, we have 2 by 2 matrix, all right, multiplying a 2 by 1 matrix. So the column of this is the same as the row of this, so we can multiply them together. So what do? Just take first row and the only column we have here. 3 times 2, we have 6, plus 2 times 3, we have 6. Then 1 times 2, we have 2, plus 4 times 3, we have 12. So 6 plus 6, we have 12. 2 plus 12, we have 14. This is the product of these two matrices. Then what if in a situation whereby we have 1, 1, 2, minus 1, 3, 1, minus 2, and we now have 1, 2, minus 2, 1, minus 3, 0. So let's compare them together. The first matrices is 2 by 3 matrix, that is 2 rows and 3 columns. While the second matrices is 3 rows and 2 columns. So the column of one is equal to the row of another, and because of this we can actually multiply them. So what do? The first row here multiply by the first column here, the first row here multiply by the second column here, then the second column here, the second row here multiply by the first column here, and the second row here multiply by what? The first column here. So this is how to go about it. 1 times 1, 1, plus 2 times minus 2, that is minus 4, plus minus 1 times minus 3, that is 3. So we are done with first row and first column. So let's do first row, second column. 1 times 2, that is 2, plus 2 times 1, that is 2, then plus minus 1 times 1, that is minus 1. Now let's do third row, second row, first column. So 3 times 1 is 3, 1 times minus 2 is minus 2, minus 2 times minus 3 is 6. Then 3 times 2, we have 6, 1 times 1, we have 1, and minus 2 times 0, we have 0. Let's see how to multiply these two matrices together. Alright, so we are going to deal with first row here and first column here. 1 times 1, we have 1, plus 2 times minus 2, that is minus 4, so that is minus 4, plus minus 1 times minus 3, that is 3. Then first row and second column. 2 times 2, 1 times 2, that is 2. 2 times 1, that is 2. And minus 1 times 0, that is 0. We are done with that. Let's move to second row, first column. 3 times 1, that is 3. Plus 1 times minus 2, that is minus 2. Then plus minus 2 times minus 3, that is plus 6. That is for second row and first column. Let's do second row, second column. 3 times 2, that is 6. Plus 1 times 1, that is 1. Then minus 2 times 0, that is plus 0. Alright? So we have 1 plus 3, that is 4. 4 minus 4 is 0. Then 2 plus 2 is 4. 3 minus 2 is 1. 1 plus 6, that is 7. 6 plus 1 is 7. So the product of the two matrices, we have 0, 4, 7, 7. So quickly, let's move to transpose of a matrix. The transpose of a matrix. Transpose of a matrix. Now, when we talk about transpose, we are simply talking about interchanging the rows and columns of a matrix. All right. So to obtain the transpose of any matrix, we just need to interchange the rows and the column. Look at this matrix, for instance. We have 2 rows and 3 columns. If A is equal to this matrix, A transpose will now be all the elements of this row, they will become column here, 3, 2, 1. Then all the elements of the second row will become second column here, 4, minus 1, 2. This is what we call A transpose. So if we have A equals 3 minus 2, 4, 1, what will A transpose be? A transpose will be 3 minus 2, that is the first row here, will become 3 minus 2 here. Then 4, 1, that is second row here, will become 4, 1 here. So this is A transpose. So anytime you are told to find transpose, what they're asking you to do is interchange rows for column. If you have matrix B to be 4, 3, 2, and you want to find B transpose, all of these 4, 3, 2, we have 3 rows and 1 column. So it will just become 3 columns and 1 row, 4, 3, 2. This is B transpose. All right, so to my left, I have this question. A is a matrix of 3, negative 2, negative 2, 1. We have to find the transpose of A and also comment on our answer. So to find the transpose, this 3, negative 2 will become our row, and this negative 2, 1 will become our column. Now you will notice that A is equals to A transpose. That is, the matrix A is equal to its own transpose. So the comment is matrix A is symmetric. Now, any matrix that is equal to its own transpose is known as symmetric matrix. All right, so we have this jump question to tackle together. If A equals a matrix of 2, 1, minus 3, 0, and I is a 2 by 2 identity matrix, we should evaluate A squared minus 2A plus 4I. Okay, first of all, let's deal with the identity matrix. That will be 1, 0, 0, 1. So 4I will be 4, 0, 0, 4. So let's talk about the A square. A square simply means 2, 1, negative 3, 0, multiplied by 2, 1, negative 3, 0. Square means you multiply by itself, all right? So 2 times 2, we have 4, 4, and this is 1. Then this is 2, negative 3 times 2, this is 6, this is 0, so this is negative 6, and this is negative 3. Alright, then 2a will simply be 2 into 2, 1, negative 3, 0. That will be 4, 2, negative 6, 0. So bringing everything together, a square will now be 1, 2, negative 6, negative 3, minus 2a will be 4, 2, negative 6, 0, plus 4i. That will be 4, 0, 0, 4. Okay, so this is negative. So that will be 1 minus 4 plus 4. 1 minus 4 plus 4 will give us 1. Then this is 2 minus 2 plus 0. That will give us 0. This is negative 6 minus 6. That is 0 plus 0. That is 0. Then this is negative 3 minus 0. That is negative 3 plus 4. And that is 1. So our final answer is 1001. So we move to the determinant of a 2 by 2 matrix. If M is the 2 by 2 matrix A, B, C, D, the determinant of M, written as bar M, these vertical bars represents determinant, all right? Or det M, DET, is given as M equals ABCD, which is equals to AD minus BC. That is, when you want to find the determinant, you have to subtract the product of the element in the ordinary diagonal, which is B and C. You subtract it from the product of the element on the leading diagonal, which is A and D. So here, what do? Is you multiply A and D together, minus you multiply B and C together. Don't forget that I already said that A and D, this diagonal is known as the main diagonal or the leading diagonal. Alright, so to have the determinant of the 2 by 2 matrix, you need to find the products of the diagonals and subtract from each other. So let's have this example. Find the determinant of P if P equals 5, 3, 2, 4. So we have 5 and 4 on the leading diagonal. So you simply say 5 times 4, that is 20, minus we have 2 and 3 on the ordinary diagonal. 2 times 3, we have 6. So 20 minus 6 is 14. So this is the determinant of that matrix. Then here we have given that A is a matrix of 3, 2, 1, 0. Find the determinant of A. So that will be 3 multiplied by 0, that is 0, minus 1 multiplied by 2, that is 2. 0 minus 2, we have minus 2. That is the determinant of that matrix. Then once you see vertical bars like this, it means you have to find the determinant of that particular matrix. So 2 multiplied by 5, you have 10, minus 3 multiplied by negative 1, you have negative 3. So minus times minus is plus. So we have 10 plus 3, and that is 13. Then here we have 6 multiplied by minus 6, that is minus 36, minus 9 multiplied by minus 4, that is minus 36. Minus times minus is plus. So we have minus 36 plus 36, and that is 0. Then for this we have x to the power of 4 multiplied by x, that is x to the power of 5, minus x to the power of 3 multiplied by x to the power of 2. According to indices, you add their powers. So that is x to the power of 5, and that is 0. So what did you notice in example 4 and 5? We noticed that the determinant of the two matrices gave us 0. So we call such matrix singular matrix. Singular matrix. A singular matrix is a square matrix whose determinant is equal to 0. A singular matrix is a square matrix whose determinant is equal to 0. So let's proceed to see how to find the determinant of a 3 by 3 matrix. So let's talk about third order determinant, which is also known as determinant of a 3 by 3 matrix. Now, Don't forget that in the case of 2 by 2, if you have 2, 1, 0, 5, and you want to find the determinant, you simply multiply the element on the leading diagonal. That's 2 times 5, 10, minus, you multiply the element on the ordinary diagonal. That's 0. So that is 10. But in the case of a 3 by 3 matrix, the first thing we need to find is we need to find the cofactors. All right? We need to find the cofactors of this matrix. And to find the cofactors of this matrix, we need to expand the matrix either across the first row or second row or third row. And while doing the expansion, we must bear in mind that the first column here is plus, the second column here is minus, and the third column here is plus. So that is the pattern for the expansion sign. So if I'm picking 3, I know that 3 should carry plus. If I'm picking 4, 4 should carry negative. If I'm picking 6, 6 should carry plus. If I'm picking 2, 2 should carry plus. If I'm picking 1, 1 should carry negative. If I'm picking negative 1, it should carry plus. Then if I'm picking minus 1, it should carry plus. 3 should carry minus, and 5 should carry plus. So let's expand this across the first row and see. So the first member of the first row is 3. So I'm picking 3, so that is plus 3. So I need to find the cofactors of 3. So what do? I locate 3, then all the rows and the columns attached to 3, I'm going to cover them, all right, like eliminating them. Then what I have left is 1, minus 1, 3, and 5. This place, this is what I have left. And this is what we call the cofactors of 3. Then the second element is 4, this one. So I will do the same thing for 4, all the column in 4 and the rows in 4. So what we have left, we have 2, minus 1, 5. Then I will do the same for 6, plus 6. Now in the case of 6, we have all the columns and the rows. We are left with 2, 1, minus 1, 3. 2, 1, minus 1, 3. Beautiful. So now we have 2 by 2 matrix as cofactors that we can work with. So this is 3 into, you now find the determinant of each of these. 5 times 1, that is 5. Minus 3 times 1, that is minus 3, so that will be plus 3. Minus 4 into 5 times 2, that is 10. Minus 1 times minus 1 is plus 1, so that is 1. Plus 6 into 3 times 2, 6. Minus 1 times 1 is minus 1, so that is plus 1. So here we have 3 into 5 plus 3, 8. Minus 4 into 10 minus 1, 9. Plus 6 into 6 plus 1, 7. 8 times 3 is 24. 9 times 4 is 36. 6 times 7 is 42. So 24 minus 36 plus 42 will give us 30. So the determinant of this matrix is 30. So you can decide to expand either across the first row like I did, or you expand across the second row, which is 2, 1, minus 3, or you expand across the third row, which is minus 1, 3, 5. But in all of your expansions, you must not forget this recurring pattern of plus, minus, plus. The first element gets plus, the next one gets minus, the next one gets plus. So how do we find the inverse of a 2 by 2 matrix? To find the inverse of a 2 by 2 matrix, number 1, swap the element on the leading diagonal. That is, we interchange the top left hand and the bottom right hand element. All right. Then number 2, we have to multiply the other two elements by -1, and 3, divide the resulting matrix by the determinant of the original matrix, meaning that we need to find the determinant of the original matrix. So let's consider these examples. Find the inverse of the following matrix. All right, so let's start with the first one. Number 1, we have 3 minus 2, 4, 1. So if I start with finding the inverse, finding the determinant of this matrix, I'm going to say 3 times 1, that is 3, minus 4 times minus 2, that is minus 8. So this is minus times minus plus, 3 plus 8 will give me 11. All right. So following the other processes, the first thing they ask us to do is we swap the positions of the element on the leading diagonal. So 1 will be here, 3 will be here. Then they ask us to multiply the other two elements, which is the element on the ordinary diagonal, by -1. So this will be minus 2 times minus 1, that is 2. Then minus 1 times 4, that is minus 4. So this is the resulting matrix. They now ask us to divide it by the determinant. So this will be divided by what? 11. So the answer will be 1 over 11, 2 over 11, minus 4 over 11, and 3 over 11. So this is the inverse of that matrix. Then the second one, we have 2, 5, 2, 5, 3, 8. All right. We have 2, 5, 3, 8. So the determinant of this matrix will be 8 times 2, that is 16, minus 3 times 5, that is 15. So the determinant is 1. So the next step is we swap this element, 8 and 2. So 8 will be here, 2 will be here. Multiply the other two by -1. You have minus 5 and you have minus 3. And they ask us to divide this by 1. If you divide by 1, you will still have this back. All right. Then the third question, we're given 6, 3, 2, 1. So the first thing is we find the determinant. 6 times 1 is 6, minus 2 times 3 is 6. And this will give us 0. Now, remember that I said any matrix whose determinant is 0 is known as what? Singular matrix. And because this is a singular matrix, it has no inverse. It has no inverse. Singular matrix has no inverse. So this is how you find the inverse of 2 by 2 matrices. You first find the determinant of the matrix given to you, and once you do that, you now swap the element on the leading diagonal, like this one now, 2 and 8. 8 will come here, 2 will come here, just like I did here. Then after doing that, you now multiply the element on the ordinary diagonal by -1. All right. And once you do that, you divide your resulting matrix by the determinant that you have gotten. And that is how to find the inverse of a 2 by 2 matrix. Let's proceed to finding the inverse of a 3 by 3 matrix. All right, so I made a claim that if you want to do third order determinant, you can expand either across the first row, the second row, or the third row. So in this chapter, I want us to verify if we are going to arrive at the same answer. Don't forget, we have plus, minus, plus on the first row, minus, plus, minus, the sign just continues like that. Then on the third, we came back to plus, minus, plus. So let's start by expanding across the first row. Expand across the first row. So what we want to do is find the cofactors of the elements of the first row. So the first element is 3, and that is plus 3. So how do we find the cofactors? Like I said, since the first element is 3, you are going to delete the row and the column that has the 3. All right, so what do we have left? We have 1, this is this, and minus 1, then we have 3, 5. Then the second element of the first row, that's 4, so that's minus 4. So taking minus 4 as the center now, we are going to delete the column that has minus 4 and the row that has minus 4. So what do we have left? We have 2 minus 1 minus 5, 2 minus 1 minus 1 and 5, 2 minus 1 minus 1, 5. Then the third element of the first row is 6, that is plus 6. So we are going to delete the row and the column that has 6. So we are left with 2, 1, minus 1, 3. 2, 1, minus 1, 3. Okay, so let's evaluate this. We can now find the determinant of this matrix. 5 times 1 is 5. Minus 3 times minus 1 is minus 3. So minus times minus is plus. Minus 4 into 5 times 2 is 10. Minus times minus is plus, so that is 10 minus 1 plus 6. 2 times 3, that's 6. All right. Minus 1 times 1, that is minus 1. Minus times minus is plus, so we have plus 1 here. So this is 3 times 8, that is 24. Minus 9 times minus 4, that is minus 36. Plus 7 times 6, that is 42. So 24 minus 36 plus 42 will give us 30. All right, so expanding across the first row will give us 30. So let us expand across the second row and see if we are going to arrive at 30. All right, so let's expand across the second row. And to do that, we are considering elements 2, 1, and negative 1. So the first element of the second row is 2 and is carrying negative, so that is negative 2. Let's find the cofactors of 2. So we are going to use 2 as the center, delete the column that has 2 and the row that has this 2. So what do we have left? We have 4, 6, 3, 5. Then the next element to 2, we have 1. That is plus 1. So for this 1, we are going to delete the column that has 1 and the row that has it. So we are left with 3, 6, minus 1, 5. 3, 6, minus 1, 5. All right. Then for the next element, we have minus 1. And minus 1 already has negative, so that is plus 1. Okay. So what are the cofactors of this one? We are going to shift this way. We are left with 3, 4, minus 1, 3. 3, 4, minus 1, 3. Okay. So we can now find the determinant of these, matrices. We have 5 times 4, that will give us 20, minus 3 times 6, that will give us 18, plus 1 into 3 times 5, that will give us 15. All right. Minus 6, so that will be plus 6. Plus 1 into 3 times 3, that is 9. Should be 9 minus 4, so that's plus 4. So this is minus 2 into 20 minus 18, that is 2. Plus 1 into 15 plus 6, that is 21. plus 1 into 9 plus 4, that is 13. Alright, so this is minus 2 times 2, that is minus 4, plus 21 plus 13. So 21 plus 13 would give us 34. So this is minus 4 plus 34, and we have 30. Don't forget, when we expanded across the first row, we also got 30. And now expanding across the second row also gave us 30. Let's proceed further to expand across the third row. So far we've been able to expand across the first row, we got 30. We expanded across the second row, we got 30. Let's expand across the third row, all right? And by so doing, we need this, all right? And we need this. So the first element of the third row is negative 1. So what are the minor what are the cofactors of negative 1? That will be 4, 6, 1, minus 1. 4, 6, 1, minus 1. Then the second element here is negative 3. So to find the cofactors, we delete the columns and the rows that has this 3. We are left with 3, 6, all right, 2, minus 1. Then we move to the last element, which is plus 5. What are the cofactors of 5? You delete the rows and the columns. We are left with 3, 4, 2, 1. 3, 4, 2, 1. So we can now solve this by finding the determinant of the 2 by 2 matrices. So this is 4 times negative 1, that's negative 4, minus 1 times 6, that is 6, and this is minus 3 into 3 times minus 1, that is minus 3, minus 2 times 6, this is 12, plus 5 into 1 times 3, that is 3, minus 2 times 4, that is 8, alright? So this is minus 1 into minus 4 minus 6 is minus 10. Minus 3 into minus 3 minus 12 is minus 15. Alright? Then plus 5 into 3 minus 8. That is minus 5. Okay, minus 1 times minus 10. That is 10. Then 15 times 3. That is minus 15 times minus 3. That is plus 45. Alright? Then plus 5 times minus 5. That is minus 25. That is minus 25. So 45 minus 25 will give us 20. That is 10 plus 20. We have 30. So we have been able to see that if you expand across the first, second, or third row, you are going to arrive at the same answer. Now we move to finding the inverse of a 3 by 3 matrix. Alright? Now the way to go about finding the inverse of a 3 by 3 matrix, inverse is represented as a to the power of negative 1. That's for a matrix A. And it is defined as adjoint of A all over the determinant of A. So the inverse of a matrix, of a 3 by 3 matrix, is the adjoint of the matrix all over the determinant of the matrix. Or you can write it as 1 over the determinant multiplied by the adjoint. So what's the adjoint of a matrix? Adjoint of a 3 by 3 matrix is the transpose of the cofactors of the matrix. So adjoint of A equals transpose of the cofactors of A. Alright, so it means we need to find the cofactors of A, then take the transpose. That will give us the adjoint that we need. All right, so how do we find the cofactors of A? We need to expand this matrix along the first, second, and third row. That is, we need to find the minor of each of these elements. So let's start with the first row. Now we are starting with first row, first column. That is A11. All right. So what are the minor of A11? We are left with 1, 2, 5 minus 1. 1, 2, 5 minus 1. All right. So you are going to take the determinant of this. Minus 1 times 1, that is minus 1. Minus 5 times 2, that is 10. So minus 1 minus 10, we have minus 11. Don't forget, this is plus. Plus minus plus, you understand? So we are going to go to A12, that is first row, second column. So we shift this here. We are left with 3, 2, minus 4, minus 1. So that is minus 3, 2, minus 4, minus 1. You take the determinant. Minus 3 and minus 1 times 3, that is minus 3. Then minus 4 times 2, that is minus 8. So we have minus 3, minus times minus, that is plus 8. Minus 3 plus 8 is 5. But don't forget, we have a negative sign here, so that will be minus 5. All right. Then let's move to A13, that is first row and third column. This is the third column. So we have 3, 1, minus 4, 5. 3, 1, minus 4, 5. So we have plus 3, 1, minus 4, 5. All right. So 5 times 3, this is 15, minus 4 times 1, that is minus 4. 15 plus 4, that is 19. All right. So we are through with A11, A12, A13. Let's move to the second row. So we have A21, that is second row, first column. So we have 2 minus 3, 5 minus 1. 2 minus 3, 5 minus 1. So this will be negative. 2 minus 3, 5 minus 1. All right. Minus 1 times 2, that is minus 2. Minus 3 times 5, that is minus 15. So minus times minus is plus. Minus 2 plus 15, that should give us 13. But because this is negative, we'll have minus 13. So we are done with A21. Let's proceed and move to A22. So we have 1 minus 3 minus 4 minus 1. So we are going to have 1 minus 3 minus 4 minus 1. And this is A22, positive. So minus 1 times 1 is minus 1. Then minus 4 times minus 3, that is 12. So we have minus 13. All right. So we move to A23, second row, third column. Second row, third column. We have 1, 2, minus 4, 5. We have 1, 2, minus 4, 5. That is A23, and that is negative. All right. So 5 times 1, that is 5. Minus 4 times 2, that's minus 8, so that's plus 8. So here we have 13. But because this is negative, we are going to have minus 13. So let's move to A31. A31 will be positive. So that is third row, first column. So third row and first column. So we are left with what? 2 minus 3, 1, 2. 2 minus 3, 1, 2. So let's find the determinant of this. 2 times 2, we have 4. Then minus 3 times 1, that's minus 3. Minus times minus is plus. So this is 7. Then A32, that should be negative. So A32, that is third row, second column. Second column. We are left with 1 minus 3 and 3, 2. We have 1 minus 3, 3, 2. 1 minus 3, 3, 2. Alright. So 2 times 1, we have 2. Then minus times minus plus 3 times 3 is 9 plus 9. So this should be 11. But because it has negative here, we have minus 11. So A33, that should be positive. A33 is third row, third column. So we have third column. What do we have left? 1, 2, 3, 1. 1, 2, 3, 1. So you write 1, 2, 3, 1. All right. 1 times 1, that is 1. Minus 3 times 2, that is 6. So that is minus 5. All right. So what will be the cofactors of this matrix? The cofactors will now be all of the results that we have gotten. So you now start arranging from the beginning. We got minus 11, minus 5, and 19. So that will be our first row. Minus 11, minus 5, 19. Then we got minus 13, minus 13, minus 13. That will be our second row. Minus 13, minus 13, minus 13. Then we got 7 minus 11, 5. We have 7 minus 11 and minus 5. So this is the cofactor of that matrix. All right. So the adjoint now, adjoint of A will now be the transpose of these cofactors. All right. So what does transpose mean? Transpose means interchanging the rows and the columns. So this one that is our first column here, we are going to make it first row. So we have minus 13, we have 7. Then our second column here, we make it second row, minus 5, minus 13, minus 11. Then we have 19. This is our third column here, we make it third row. We have 19, we have minus 13, and we have minus 5. So we have found the adjoint of that matrix. Next thing to do is to find the determinant of the matrix. Alright, so the next thing we need to do now is find the determinant of the matrix A. And it's going to be quite simple since we already know our cofactors. So if you are expanding along the first row, alright, we'll just have 1 multiplied by the answer we got for A11, that is negative 11, then plus 2 multiplied by the answer we got, that is minus 5, then minus 3, this one, multiplied by the answer we got, that is 19. So this is minus 11, minus 10, minus 57, yeah. So minus 11 minus 10, that is minus 21. Minus 21 minus 57 is minus 78. So the determinant of A is minus 78. So what will be A inverse? So A inverse is 1 over the determinant multiplied by the adjoint. Therefore, the inverse of that matrix will be minus 1 over 78 into the adjoint. So our adjoint is this, minus 11, minus 11, minus 13, 7, minus 5, 19, minus 13, minus 13, minus 11, minus 5. So this is the inverse of that matrix.